My project is on sea turtles and the Earth's magnetic field. Sea turtles live in almost every ocean basin throughout the world, and they travel thousands of miles to find food and protection against predators. They also come back to lay their own eggs on the same beach that they were born on, and they are able to do this by using the Earth's magnetic field for navigation. The Earth's magnetic field extends from the Earth's interior out into space, and it is generated by electric currents from the motion of convection currents of molten iron in the Earth's outer core. There's also a magnetic dipole that is at an angle of 11 degrees from the Earth's rotational axis. The magnetic field's magnitude also ranges from 0.25 to 0.65 Gauss, depending on your location on Earth. Here are some models of the Earth's magnetic field, and the geographic North Pole is actually a magnetic South Pole on the Earth because we know that magnetic field lines always point towards the south end from the north end of a magnet. So, looking at the diagram on the left, we can see that the field lines are pointing towards the magnetic South Pole, which we know as the geographic North Pole, which is where your compass points to when you're heading in the direction of north. This is a calculation you would use to when you're finding the magnetic field when you have current. So we know that the Earth's current is around 1.8434 times 10 to the ninth amps. And I found the magnetic field if I was standing right on top of the magnetic North Pole with respect to the center of the Earth. So we know that the radius of the Earth is 6.3 times 10 to the 6 meters. So when you plug both of those numbers into this equation, it turns out to be 2.926 times 10 to the negative fifth Tesla, which converts into 0.293 Gauss. And the magnetic field also always has a direction because it's a vector. And if you're standing on the magnetic North Pole, which is the geographic South Pole, the magnetic field would be pointing straight downward. This idea also relates to biology because biologists would use physics in the research when they were finding more about the genetics of sea turtles. So, biologists originally thought that sea turtles would have similar genetics if they were born on beaches that were close to each other, but that actually wasn't the case. Sea turtles that have similar genetics actually were born on beaches that had similar magnetic structures, which is pretty interesting. So, sea turtles are able to navigate throughout the ocean with using their geomagnetic imprinting. So, they're able to perceive the magnetic field's intensity and its inclination angle. And that's how they're able to get back to their original beaches that they were born on. But actually this sometimes results in errors of nesting because they sometimes go to beaches that are magnetically similar to the beach that they were born on, but it's actually not that exact same beach. And this is me when I was younger releasing some sea turtles into the ocean in Mexico. So I've always had a love for sea turtles. Thank you.